We're in section 21.5 today, and as we figured out on Monday, we don't want to be in section 21.4 any longer than we need to.
I tried doing problem 27 on my own. I couldn't do it.
You couldn't?
No,
That'll teach you. Want me to do number 27?
no, that's cool. We did it already.
I did it?
Yeah, we did it.
If I did it, then you can do it.
Yeah.
All right, so
I'll try to do it by myself.
if I have a straight line like that, that straight line has a slope that's m, and it's got a y-intercept that's b, and it's got a solution, an equation y is equal to mx plus b. So if the derivative of the function is the slope of the function, if that's true, and the equation is y equal to mx plus b, then that slope must be what? Must be m. Alright, so what did I do? How come the b doesn't matter? Well, because the slope is the slope. It didn't matter where it crossed where it intersected with the y-axis, right? So b didn't matter. It only mattered what the slope was. So if I have an equation y is equal to x to the 14th power, and I want to find the slope, well, that just would be the derivative of that. And I could use the procedures in chapter 21.4 to do that, right? But I don't particularly care to do that, so we'll look at something different. We'll look at y is equal to 2x squared plus 4x minus 3. Too hard. Can't possibly do it with the procedures we have in chapter 21.4, right? So we have a rule when all else fails, and it says if y is equal to x to the n, then y prime is going to be n x to the n minus 1. And we go back up and say, if I come back up to this equation, and let's see, m x to n minus 1, that's x to the 0, so that'd just be an m, right? And the derivative of nothingness over here, no, x to the 0, I'm not going to go x to the minus 1, so that guy's going to go away. Alright, so now I can go and use that rule and say y prime is 4x plus 4. And then I could go and I could take a second derivative, and I could say the second derivative is just 4. And then I could go on and say that well, if this derivative was position, if that function was a position function, then the derivative of position with respect to time is velocity. So that would be my velocity equation, and the derivative of velocity of it is acceleration. So if I have a position formula, then its first derivative, besides from being the slope of the first guy, is also the velocity of the equation. The second derivative is the acceleration. If I have some other type of equation, I'm just just have something that looks like this, whatever that is. Then the first equation is the function is that guy. The first derivative of that guy is the slope. When I have the slope equal to 0, then I end up with a local minimum and maximum of the equation. So when I solve it, I can find where the minimums are and the maximums are by using the first derivative. If I go and I take the second derivative of the equation and I set it equal to 0, that tells me, so this guy's my slope. The second derivative is my curvature. So if I set that equal to 0, now I know when I change from concave down to concave up. From concave up to concave down. From concave up to concave down. So I can find intervals in my curve where those things happen, and that's what I would use that for. So my first equation is on page 681. The derivative of x to the n is nx to the n minus 1. Now, if you look in the back of your book, you'll see that you don't have to memorize that because it's sitting right there. Number 3 in the back of the book, derivative formula. So you have to take a derivative. You don't remember the rule, who the heck cares? There it is in the back of the book. Look at it. All right, so now I've got y is equal to 2. Okay, so there's an xy plane, and here we are, y is equal to 2. What's the slope of that equation? 0, right. So the slope is equal to 0, so the first derivative must be 0 because that's the slope. So the rule says if I take the derivative of a constant with respect to some variable, I will get 0. So it could be with respect to time, with respect to x, with respect to z, or whatever. If it's a constant and I take its derivative, it's going to be 0. The derivative is going to be a linear thing. So if I take the derivative of c times x of x with respect to x, that's going to be the same as that constant times the derivative f of x d of x. So when I had y is equal to 2x squared plus 4x plus 4, and I took its derivative, I went 2 times the derivative of x squared plus 4, the derivative of x, plus the derivative of 4. And then I did this in my head, and then I applied my rules and said that's 2 times 2x. This is 4 times 1. This is 0. And then I wrote down 4x plus 4. In fact, I skipped the center step altogether. I skipped this top step altogether. I just wrote down the answer, is all that I did. Okay, turn the page over. On the bottom of 682, we have 2 other rules that deal with linearity of the derivative. So if I have the derivative of f of x plus or minus g of x, we'll do them both at the same time with respect to x. And that's going to be the derivative of f of x with respect to x plus or minus, depending on which one he is, derivative of g of x with respect to x. So if this guy's plus, then this guy's plus. If that guy's minus, then this guy's minus. And those are the only rules that we have. Well, what if I had y is equal to 3x to the 5 halves x, and I wanted to take that derivative, y of x, 5 halves x. Who did that? To the 5 halves. And so that'd be 3 times 5 halves x to the 5 halves minus 1. So that'd be 15. 15 halves x to the 3 halves. So what goes as an exponent there could be any real number. I could have y is equal to 4x to the square root of 3. And so y prime would be 4 times the square root of 3, x to the square root of 3 minus 1. Whatever that is. Perfectly okay. Okay, we'll work some problems. We only have to go up to number 45. Okay, so we'll start with 2. Alright, number 2. Gee, I like the color in here better, don't you? Is the color better up there? I never put down that I didn't like the color in the other word. Y prime is equal to 0.
I can hear you better in here too.
Bummer. I have to quit talking. Number 4.
Wait, you still up?
Yeah. So y is a constant. The derivative of the constant is in fact 0. Y is equal to x to the 16th. Y prime, I put the 16 out in front. X, I subtract 1 from it to the 15th. Number 6. Y is 6x minus 2. Y prime is 6. All right, we'll talk about some English stuff now. So I could have the derivative of the function with respect to x. I could have f prime x. I could have capital D f of x. All those mean the same thing. They're interchangeable in what they mean. They all mean the same. So I can go y prime, or I could say dy, or I could say dy with respect to dx. They all mean the same thing. If there's some weirdness going on with the capital D as to, let's say my function is in respect to x, but I'm taking the derivative with respect to y, then it'd be capital dy. But the derivative with respect to y of a function in only x is going to be 0. So that's would be an interesting thing. Okay, so that's just spelling. Back to number 8. Y is equal to x. Y prime is equal to 1. Number 12. Y is equal to x squared minus 4x plus. I think that hearing me in the other room is just solved by sitting up close, right? Y prime is equal to 2x minus 4. Am I going fast enough? Number 16. Y is equal to 4 minus 6x minus 5x. Now, why would I go and write it that way? Why wouldn't I put the x squared term first? And I do it because of the negative signs. It's spelled correctly with no negative sign up in front. If I were to go minus 5x squared minus 6x plus 4, I would look at that as a misspelling. So y prime is equal to 0 minus 6 minus 10x. Now I would call that misspelled, and I would go minus 10x minus 6, because now they're both negative, and I'd put the highest order x term first, is what I would do. Now, does it matter? No, it's only aesthetically pleasing is all we're talking about there. So both those answers are perfectly okay.
Matters by significant digits.
Yeah, like significant digits. Only count if you have 100. Yeah, number 24. I'm not sure I can even write number 24. Y is equal to the square root of 10, x to the 10th, minus the square root of 7, x to the 7, plus the square root of 5. Is there a pattern here? X to the 5th, minus the square root of 3. All right, so y prime, 10, square root of 10, x to the 9th, minus 7, square root of 7, x to the 6th, plus 5, square root of 5, x to the 4th. The last guy becomes a 0. I don't write anything. All right. Now we're going to look at number 26. We're going to find the value at some place. So we got y of x, probably y of x is 3x squared plus 2x minus 1, and we want to find y at y prime at minus 1. That's what we're looking for. Okay, so y prime 6x plus 2, y prime at minus 1, minus 6 plus 2 minus 4, minus 4. So the slope of this curve at x is equal to minus 1 is going to be a minus 4. That's what that's saying.
You just did number 25.
I did? All right, no problem. There we go. All better. So if I graph this function when x is 0, y is going to be minus 1. So it's going to pass through that point. It's going to be concave up. Is it going to go any further negative than that? When y is minus 1, when x is minus 1, I'm going to pass through 0. So it's going to go through. So it's probably something that looks something like that. And when I'm at minus 1, the slope right there is minus 4. Now, this probably goes, well, it can't go any more negative than that, can it? X is minus a half. I don't know. I'd have to put it in my graphing calculator to find out. Number 28. Y is 6x cubed minus 5x plus 3, and we want a at minus 2. So y prime 18x squared minus 5, y prime at minus 2 is 18 times 4 minus 5. What's that, 102? No, it's not. That's 40, 72. 72 minus 5 is 67. 67. And I didn't bring my real calculator with me, so I really don't know.
You're right.
I am? All right, thank you very much. All right, we'll try 34. No try though, Yoda doesn't let us just try. So we're going to do 34. Y is equal to 3, 4x squared minus 6x to the 4th plus 5x to the 9th. And we want a at minus 2. All right, so y prime minus 8x minus 24x cubed plus 45x to the 8th. And we want y prime at minus 2. Right, so that's a 16. This is going to be a plus sign. 8 times 24. And my calculator isn't going to work. Alright, so 8 times 24, that's 2, 3 to carry,
192.
16, 192, plus 45 times 2 to the 8th, which is 256. 256, It is? Alright, so anybody got a good number for that? I probably have a calculator.
11,520.
11,520.
All of it together? I don't know.
Oh. Well, whatever it is. I'm sure our calculator can calculate that. Now, we're only going to 45, so that means we better do number, well, we're going to have to do 38, right? No, 38 is a falling object. We'll have to do 40, because 40 is an electrical problem. So, in an electrical circuit, V is equal to T to the 4th, where T is in seconds. Find dV dt when t is 3. Okay, so at t equals 3. Okay, so v prime is equal to 4t cubed. The v prime at 3, 4 times 27, which is
108.
108. 108. All right. Well, that was okay. Okay, 42 is next. That wasn't much of an electrical problem because no circuit does the voltage change with the fourth power of t. I mean, how many seconds do you have to go before you're in the megavolts and the gigavolts and the teravolts? I mean, give me a break. So y is equal to the cube root of x. Now, you wouldn't write it that way. You'd write it x to the 1/3. And then you'd say y prime is 1/3 x to the minus 2/3. Right? And then you'd say, well, I wouldn't want that because that would be a negative exponent, right? So I had 3, the cube root of x squared. And then I'd say, well, I don't want a radical in the denominator. You know, I wasn't born yesterday. I can't have that. So 3x cubed, so I'm going to multiply top and bottom 3x squared by the cube root of x, cube root of x. And then finally I get a final answer of cube root of x divided by 3x. All right. So that would be the exact okay answer for a 9th grade math class, right? Except you wouldn't be taking the derivative. Now, in calculus, it turns out that we don't bother to rationalize the denominators anymore. It's a pain in the butt, so we don't do it. So there's nothing wrong with 1 divided by 3, the cube root of x squared. So that'd be a perfectly okay thing to do. Unless it was Dustin and he had 100 on the test already, then I'd probably have to take 0.1 off for that. Yeah. But other than that particular case, I probably, well, most of you would already miss something by then anyway, right? So it wouldn't be an issue. So, but if you have to rationalize the denominator, that's how you would rationalize it. And all right, we'll do 44, and then we'll go on to the next section. Number 44. Y is equal to 4 over x cubed. Now, we wouldn't leave it like that. We'd say y is equal to 4 x to the minus 3. And then we'd say y prime is minus 12 x to the minus 4. And we would be all done. But I don't have a rule for taking a derivative if it's the numerator. I'll have a rule later on. I just don't have a rule now. So I'd have to change it to a negative exponent thingy in order to follow the rules that I have. All right. So now we're in section 21.6, and we have if y is equal to xv, then y prime is going to be xv prime plus x prime v. So if I have the product of two functions, I take the derivative of one times the other plus the derivative of the one I didn't take the derivative of times the other guy. And well, that's good. I did that. Now, the other rule we have is if you have y is equal to some function on the top divided by some function on the bottom, then that's a quotient rule, and you're going to have no, it's a pain in the butt to do it that way. Okay, so y is equal to u over v. Yeah, that's better. Y prime is going to be v u prime minus u v prime divided by v squared. Now, so I have y is equal to x cubed divided by x to the fourth. And I want to find y prime. Would I use that formula? No, I wouldn't. I would simplify this down to x to the minus 1 and call this minus x to the minus 2. All right. So, but if I had to take a quotient and there's no harder other way to do it, I'd do it that way. Look in the back of the book. You see you have that quotient formula, number 8, sitting there in plain sight to look at if it's time to use it. If you have to use it, you use it. All right, well, those are the only rules we have, so that means we can solve problems again. Now we have to remember what rules we have so that we can use them, right? All right, number 2, I have y is x cubed 3x squared plus 2x plus 1 minus 1. All right, so y prime is going to be the derivative of the first guy, 3x squared, times the second guy, plus the first guy times the derivative of the second guy, and I'm done. Now, we could go and combine terms, right? We could go and make it look different than that. There's no need to. This is a tech math combined class with pre-calculus. But I could continue, if I wanted to, and say y prime is equal to 9x to the fourth, and then 6, and no, 9 plus 6, 15. 15 x to the fourth plus 8x cubed minus 3x squared. So I could do that, but that's not required. This guy here can be my final answer, perfectly okay. It's assumed that you can do 9th grade algebra and get the other guy. Okay, so we don't need to see it. I know that's boggles the mind, but that's what it is. Okay, we'll do number 8. We're just not going to do it in green. Y is equal to 3x cubed minus 1, 2x minus 1. So we're going to use y. If y is uv, then y prime is u prime v plus uv prime. If I had a plus sign there, that would be wonderful. All right, so that being the case, y is equal to 9x squared, 2x minus 1, plus 3x cubed minus 1 times 2. And again, that would be perfectly okay. There's no reason to go on past that. We just want, it just said, it didn't say take the derivative and simplify, right? If it would have said that, then we'd have to go on. But it didn't say, it just says take the derivative. Did it say take the derivative and simplify? Blah, blah, blah. I don't know. Too many words there, I have no idea. Find the derivative of the product as given using the formula for the derivative of the product, and B, by first multiplying. Oh, they want me to do it 2 different ways? Oh, what a bunch of losers. Alright, so I could have, B, said y is equal to 3x to the fourth minus, 6x to the fourth minus 3x cubed minus 2x plus 1. And then I could have said the derivative is 24x cubed minus 9x squared minus 2. Is that what I have there? I don't know. What's 18 plus 6? 24. Alright, so I got that. There's that guy. He's there. And there's the minus 2 right there. Yeah, so I have the same thing. So I could multiply it out and take the derivative too. But sounds like more work to me. Alright, well, let's move on to number 10. Number 10. Find the derivative. Alright. Y equals x cubed. Is it really x cubed? X cubed plus 2x minus 7 x squared plus 4x minus 2. Y prime equals 3x squared plus 2 x squared plus 4x minus 2 plus x cubed plus 2x minus 7 2x plus 4. Much better. Okay, good enough. 14. Alright, we're going to do it my way first, and then we're going to do it the book's way second. Okay, so we're going to do it twice. Y is equal to 3x divided by x minus 4. So the Doug Corderville way, y is equal to 3x times x minus 4 to the minus 1. Y prime equals 3 times x minus 1 to the minus 1 plus, and we'll make it a minus sign, minus 3x x minus, is it a 1? No, it's a 4. X minus 4 to the minus 2. And then I'd rewrite it 3 over x minus 4 minus 3x over x minus 4 squared. I could find a common denominator, right? So I'd have 3x minus 12 minus 3x over x minus 4 squared, which is minus 12 over x minus 4 squared. Okay, so that'd be the Doug Corderville simple man, easy way out, because I didn't have to remember the quotient table to do it that way, formula. But if I remember the quotient formula, because it's in the back of my book, I have d of u over v is equal to something over v squared. And it is the guy on the bottom, derivative of the type on top, minus the guy on top times the derivative of the guy on the bottom. Okay, so that's what it's supposed to be. Now do we remember what the formula was? Alright, so I had 3x over x minus 4. Okay, so the derivative of 3x over x minus 4. It's back to x. Alright, so the guy on the bottom, x minus 4 squared. Okay, guy on the bottom, x minus 4 times the derivative of the guy on top, 3, minus the guy on top times the derivative of the guy on the bottom, 1. 3 times 4 is 12. I have 3x, I have minus 3x going away, x minus 4, the quantity squared. So I end up with the same answer both ways, and maybe it was easier doing it the book's way, but on some test sometime when I didn't have my book open, it would have been easier to do it my way. More intuitive. Is it more intuitive? I don't know. Hard to say. But if I have the book open and I'm using the formula, then that would be okay too. Number 22. Y 3x minus 7 over x squared minus 2. So we'll do, the book is open, so we'll do it the book's way. The derivative of u over v, we have v squared, we have v, we have u, we have minus, that's u prime, u v prime. And then I look to make sure I got it right. And guy on the bottom, yeah, okay. That being the case, y prime equals, so on the bottom I got x squared minus 2 squared. On the top, the bottom guy, x squared minus 2 times the derivative of the top guy, minus the top guy times the derivative of the bottom guy. Okay. Then we probably combine things. So let's say I got x squared minus 6x squared. So I got minus 5x squared. And then I've got minus 14x minus 6. And then I would probably object to that, because that looks like a misspelling. Does that look like a misspelling to you? Can I factor? If I can factor this into an x squared minus 2, which I can't do, so I guess I won't bother. But we normally wouldn't leave a minus sign under everything, so we'd call it minus x squared plus 14x plus 6 over x squared minus 2 squared. And we'd probably call that done. That looks pretty much done.
What about the 5?
What 5? You mean this 5 here? Is that better? Yeah. Somebody dropped the 5? Who did that? Steve, was that you? You dropped the 5?
Yeah.
Typical. I tell you, I gotta keep an eye on these guys. Okay, I guess we'll do 28. Number 28. F of x minus 2, x squared plus 5, and I want to find f prime at 3. That's what I'm looking for. So I'm looking for a number. Okay, so f prime is equal to, on the bottom I get an x squared plus 5 squared. I get, what do I get? I don't know. I get the guy on the top. No. Yeah, I get the guy on the bottom. X squared plus 5 times the derivative of the guy on the top, which is 1, minus the guy on the top times the derivative of the guy on the bottom, which is 2x. All right, now I could simplify that, but because I want f prime at 3, why bother? So f prime at 3 equals, okay, so I've got 9 plus 4, so I got 14 minus, I got a 1, I got a 6. divided by 3 squared is 9. 9 plus 5 is 14. 14 squared is what? 196?
Yep.
Really?
Mhm.
It is?
Mhm.
Wow. So I got 8. 8 over 196. And 4 ought to go into both of those, right? So this is going to be 4 over 2. That's a 2. 4 goes into 8 4 times. That was good. 2 over 49. That's not right, is it? Yes, it is. Wow, that's right. All right. Lucky guess. Okay. We're not really running out of time, but we are running out of material. So that really is pathetic, I know. Okay, 32. 32. We want the derivative at x is equal to minus 1. No, we want the equation of the line tangent to the curve. Okay, so we got a curve. Y is equal to 1 over x plus 3. And so we want the equation of the line tangent to the curve, y equals 1 over, okay, so that's what we want. Okay, so we're gonna change this to x plus 3 to the minus 1. We're going to find the first derivative. Minus 1 x plus 3 to the minus 2 minus 1 over x plus 3 squared. Now, so the curve, the slope of the curve at x is equal to minus 1 is going to be y prime at minus 1. Alright, so I put a minus 1 there, I get a 2, I square the 2, I get a 4, minus 1/4. So I know the slope of the curve is minus 1/4. I know okay, and I know I've got a point that's on the curve. The point is on the curve at minus 1 and minus 1 1/2. Minus 1 1/2 is a point on the curve. Okay, so our point slope formula says x minus x1 is equal to slope of, no, y minus y1. Y minus y1 is the slope x minus x1. Alright, so that's our formula. I think that's in the front cover of our book. Yes, it is. There it's sitting in the front cover of the book on the left-hand side. 1, 2, 3, 4, 5, 6, 7, 8 up. And so I can't possibly forget it. So y minus 1/2 is equal to minus 1/4 x minus a minus 1. So we're executing the point slope formula. Y minus 1/2 equals minus 1/4 x minus 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 1/4. Okay, I would multiply everything by 4, so I get rid of quarters, and so I got 4y plus x is equal to, okay, this is minus 1, this is minus 2, which makes this a plus 1. Right? So this is minus 2, comes over here, becomes a plus 2, minus 1 becomes a plus 1. Alright, so we'd write that as x plus 4y is equal to 1. That would be okay. Or we could write it as y is equal to minus 1/4 x plus 1/4. That would be okay too. So that would be slope-intercept form, and that would be general form. Be perfectly okay. All right, looks like we need to do number 33 and number 34. 33. Yeah, I guess so. So V is equal, how many believe V is equal to IR? Anybody out there believe that? I don't think so. Not little r. V is equal to I big R, right? It's this little r garbage. The voltage, V is equal to IR. Find the derivative of the voltage with respect to time at t is equal to 3 if the current is 6 plus 0.23 t cubed. Okay, so V is equal to 6 plus 0.02 t cubed r. Alright, so I got that. dv dt, the derivative with respect to t. So r is a constant. It can still stay there. 0.06 t squared r. And then we want at time t, so v prime at 3, okay, 3, that's 9. 9 times 6 is 54. 54.0054 r. Okay, I think I may have done that right. Anybody care if I did it right or not? Probably not. Okay. Now we do have maple. We'll do maple on 34. Number 34. If V is equal to IR, then I is clearly V over R. That's the same formula, right? And I want di dt, change in current, change in time. All right. And what do I know? At t equal 10. Okay, I could do that. Wow. V is equal to 40 plus 0.1 t squared, and R is equal to 60 plus minus 0.01 t. Okay, so I is equal to the voltage 40 plus 0.1 t squared divided by 60 minus 0.01 t. I prime is equal to, and on the bottom I have 60 minus 0.01 t squared, and on the top I have the bottom guy 0.01 t, the derivative of the top guy 0.2 t minus the top guy 0.1 t squared, derivative of the bottom guy 60 minus 0.02 0.01 whatever, the 60 goes away. Dum-de-dum. Can't even take a derivative. Minus 0.01. Oh, that can't be right. Is it getting too late in the day? Alright, so the guy on the top, on the bottom, times the derivative of the guy on top, times the derivative of the guy on the bottom, minus 0.01, times the top guy, 40 plus 0.1t squared. Alright, now I did all that. T is equal to 10. Okay, so I want I prime at 10. Alright, so 60 minus 0.1 times 2 minus. I'll minus 0.01, 40 minus 10 plus 10 divided by 60 minus 0.1 squared.
0.01.
No, because t is 10, so 0.01 times 10 is 0.1. And okay, so maybe I did that right, who knows. 59.9 times 2 minus plus 50, 0.5 divided by 59.9 squared. And so you run that through your calculator to get the right answer. Let's put Maple on and see what it thinks. And so we want the derivative with respect to t of, oh, thank you very much. Give me back control of something. I don't care what. The V guy. 40 plus 0.1 times t squared divided by 60 minus 0.01 t. Oh, way to go. That was good. That was excellent control of my little finger. Okay. We'll say dy. dy equals, what happens to the equal sign? And if we use one of those guys equal, then we can put the minus whatever it is and it'll tell us the right answer. Colon, boom. Okay, is that what I got? Something that looks like that? All right, now we want dy at 10. Oh, you sucker thing. All right, how do I do that? T, oh, it's a, I know what I did wrong. Maybe. Capital D. D. Yeah, thank you very much. Thank you, so wonderful. So, yeah, okay. So back up to what we're doing. dy of t equals that. Remember the table assignment, okay. Error, invalid left side in assignment. Invalid left side All right, we'll do it again. See if it'll just do a lookup thing. Okay, function definition. Okay, that's much better. All right, so what are we doing wrong here? T equals 10. That doesn't look like a 10. 10 ty t. T equal 10. Error. 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 T is equal to 10. An invalid input. Receive 10, which is not valid for the second argument. Okay, we'll try again. Boom. Boom. Oh, typical thing. Eval loading. That guy. It just isn't cooperating today, I can tell. I got that. I got that. Eval subs subs t equals 10 comma. Okay, we're done. Just ain't gonna work. Now, why is it? Oh, I know why it is. I use it so seldom that can't make it work. All right. Yeah, what's the rule? You do it 10 times in a row, it doesn't work, you quit, right?